Morning everyone. So till now we have studied different methods to solve first order differential equation, mainly variable separable, equation reducible to variable separable, homogeneous equation reducible to homogeneous differential equation, exact differential equation, and integrating factor. Today we are going to study a special type of differential equation, which is linear differential equation. So to understand it, let's try to solve y dash plus p of x y is equal to q of x. Please do try to solve it by yourself using the methods which we have studied. So equation 1 can be written as p of x y minus q of x dx plus dy is equal to 0. So in the form of m dx plus n dy is equal to 0. Now let's try to see is it exact or not. So here m is equal to p of x y minus q and n is equal to 1. So clearly not exact, because del m by del y is not equal to del n by del x. But if I compute 1 by n del m by del y minus del n by del x, so see what is del m by del y. It is p of x and del n by del x is 0, and 1 by n and n cancels out, so it becomes p of x only. It means that the integrating factor mu is equal to e raised to the power integration px dx. So now if I have to solve the given differential equation, which is 2, so I multiply it by, or even 1, I multiply it by, so multiply equation 1 by e raised to the power p of x dx. So if you multiply it, it comes out to be y dash e raised to the power integration p dx plus p y e raised to the power integration p dx is equal to q e raised to the power p dx. Now this is an exact differential equation. I know how I can solve it, but it can be easily solved using the concept of inspection, because if you see the left hand side, the left hand side is d by dx of y e raised to the power integration p dx, and right hand side is this one. If I integrate both the sides, because I am looking for the value of y, so y e raised to the power p dx is integration q, because I am integrating both the sides, so q e raised to the power p dx plus c. So this gives me the solution of the given differential equation, which means that if I have the equation of this form, y dash plus p of x y plus q is equal to q of x, then I don't have to solve it again and again. I can directly write down its solution, and the equation of this form is known as the linear differential equation, whose solution is given as follows. Yes, so this is the another type where, for example, we identify the homogeneous equation. We know that we have to substitute y is equal to vx. In the case of the exact differential equation, we know that how to directly write down the solution. Similarly, in the case of the linear differential equation, we can directly write down the solution. For a better understanding, let's solve few questions. So sec x y dash is equal to y plus sin x. If you recall linear differential equation, it is y dash plus p of x y is equal to q of x. So right now the given equation is not in this form, so first try to convert it. So the given equation becomes y dash minus cos of xy is equal to sin x. So this is a linear differential equation, and now I know that how to solve it. To solve it, I need the value of e raised to the power integration p dx. So now e raised to the power integration p dx, so what is p? Minus cos x, so therefore it becomes e raised to the power minus sin x. So p of x is So it means the solution would look like y e raised to the power minus sin x, then integration q of x, which is sin x cos x, then e raised to the power minus sin x dx plus c. We cannot leave the answer at this stage, we need to integrate it. So to integrate it, e raised to the power minus sin x is there, it means I can take sin x is equal to t. So if I take sin x is equal to t, I have cos x dx is equal to dt, and this term would become integration of t e raised to the power minus t dt, which is minus t e raised to the power minus t minus e raised to the power. Now I can substitute the value and that gives me the required answer. Let's try to solve one more question. So solve e raised to the power y minus 2xy y dash is equal to y square. Spend some time over it because it's a little bit tricky, that's the hint. So if you see it and if you write it in terms of dy by dx, so dy by dx is y square by e raised to power y minus 2xy. So nowhere you can write it as in the form of y dash plus p of xy is equal to q of x. But if you write it as dx by dy, so dx by dy, which is e raised to the power y by y square minus 2x by y, or which is dx by dy plus 2x by y is equal to e raised to the power y by y square. It means it is a linear differential equation. It is a linear differential equation in x. So now the solution would be, or to find the solution, the first thing I need is e raised to the power p dy instead of p dx, where p is 2 by y. So e raised to the power integration 2 by y dy, so 2 log y and e raised to the power log y square, which becomes y square. So now the solution is, instead of y you have to write x times e raised to the power p dy, then q of y, which is e raised to the power y square, multiplied by e raised to power p dy plus c. This implies xy square is equal to e raised to the power y plus c. Let's see one more question. Please do try to solve all of them by yourself. Y minus x plus xy cot x plus xy dash is equal to 0. So let's see how it comes out to be. So xy dash plus 1 plus x cot x y is equal to x. So it looks like that it may turn out to be a linear differential equation, which means y dash plus 1 by x plus cot x, which is my p of x, y is equal to 1. So it is a linear differential equation where p of x is 1 plus x plus cot x, so cos x by sin x. So now e raised to the power integration p of x dx is e raised to the power log x plus log sin x. So to integrate cos x by sin x, take sin x is equal to t, that gives you cos x dx is equal to dt, and 1 by t, integration of 1 by t dt is log t. So this becomes e raised to the power log x sin x, which is x sin x. So now it's straightforward. So solution is y multiplied by e raised to a p dx, which is x sin x, and integration x sin x, because q of x is 1, dx plus c, which is minus x cos x plus sin x plus c. So that's all from today's class. In the next class we will see again a particular case of differential equation which can be reduced to linear differential equation. Thank you very much.